ladies and gentlemen, what I want to do is I want to take a first look at this bell ringer. And you're going to get into small groups discussions later on. And what you're going to do is I want you to look at and tell me, to other organisms, this animal was a source of energy. How might have animals used it to survive? Second question to guide us in discussion is, how might plants have used it to survive? And the third thing is, how might this animal's matter continue to cycle even after its nutrients have been consumed by predators or absorbed by, as you see, the plants in there? It's going to be really important. And that's going to lead us into our first action today of doing the basics. The topic one I want to do is the basics of biogeochemical cycles. And when you think of the word biogeochemical cycle, what should come to your mind is that bio means life, geo means geology, and cycles or chemicals means chemicals. So you're taking chemicals that are found in the geology or the earth that deal with life, and we're just cycling them over and over again. Well, the purpose of this is because all living things require matter and physical processes such as weathering. So you're just constantly going to be moving matter from one form to another. It's never, ever, ever used up. Matter is always just transformed. Let me repeat that again. Matter is never used up. It's just merely transformed from one form to another. So the molecules are always being passed around. So why? The purpose of that, the purpose of the cycles is that energy is transformed into usable forms from one organism to the next. For example, in the nitrogen cycle, plants can't take nitrogen from the air. So they got to have something in their roots that are going to change that nitrogen into a form that is useful. So that's the purpose of what we're going to be looking at today. Right? Now, that ends up topic one, the basics. Remember, bio means life, geo means geology, chemical is chemicals like nitrogen, phosphorus, and we never are going to use something up, it's just merely transformed. Now, when we look at cycles, what cycles are we talking about? Well, we can have the water cycle, okay? We can also have the carbon. I'm going to scroll here a little bit. We have the water cycle, carbon cycle, nitrogen cycle, and the phosphorus cycle. So in topic 2 of your notes, we want to know 5 or 6 key elements that have to be in our life at all times. And they're carbon, hydrogen, oxygen, nitrogen, phosphorus, and we can add sulfur. We're not going to look at sulfur in the classroom, but we want to look at basically CHONP. Okay, so CHONOPS. That's a good way to remember it. The acronym CHONPSE. CHONOPS. That's the key elements to life. So now if you take CHONOPS, carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur, those are elements that are going to be just transformed and never used up throughout cycles. So going to topic 3 of your notes, it doesn't matter what cycle I'm going to show you. They all have some things in common. Now your notes has 4 boxes. We can combine 2 of these boxes together. It doesn't really matter. But all elements have the following in common with the cycles. There's always an atmospheric part right here. That means it's always going to be found either in the air or in soil and water. Well, it's then going to be moved into the food pyramid. Now we're going to learn how, but that's the next step. It enters the food pyramid. These 2 can be combined. So this can go into your 3rd box, called entering the food pyramid, and then it goes through the food pyramid from autotrophs to heterotrophs at the top. Well, then there has to be a way that we get it out of the ecosystem or out of the cycle. And typically that means you're either going to breathe it out if it's a gas, you're going to pee it out if it's a chemical, you're going to poop it out if it's a chemical, if it's in a liquid form, okay, liquid form, maybe a solid form. If you die, that's going to get the elements out, because when you die, you decompose. And that's going to break the elements out from your body, and it's going to be reabsorbed by the rest of the ecosystem. And once you're out of the food web or food pyramid, you are then back in the atmosphere. You either go back in the air as a gas, or you can be on the soil and then you'll be compressed into rocks. Right? That's how all the cycles have these in common. Right? So there's always an atmospheric part, there's always a food pyramid part, and there's always a getting out of the food pyramid part. Let's just quickly take a look at some examples of the cycles, and as I go through this is a review of topic 1 and 2 again. Okay. We're first going to look at the water cycle. Now with this, I want you to look at your notes and notice that I want you to know some key terms and how we're messing it up. And we're going to play with all these cycles in class. So please just get the general idea here. Well, with the water cycle, what's really neat is that 90% of water evaporates from the bodies of water. That means it comes from the ocean. 10% of the water evaporates from the surface of plants. So we get most of our water put back in the atmosphere by evaporation. But 10% of it does come from plants, and we call that process transpiration. That's where water leaves plants. It's called transpiration. Well, with that, about 69% of all fresh water is found in the ice caps and glaciers. Now, you know about global warming and so forth. Imagine the problem if we melt all our glaciers right now. Well, with this, with the water cycle, if you take a look at it, a couple of key words that you want to know is transpiration. That's where water goes into the atmosphere as from plants. It's called transpiration. It's then found in the atmosphere. It's going to precipitate down, enter the food web, and leave by evaporation or transpiration again. Now, think about how we're messing this up. If 10% of water comes from transpiration and you cut down the rainforests, you can have a global effect of change, climate change, because you're not having the same amount of water put back in the atmosphere. Let's take a look now at the carbon cycle, which is a little bit more complicated. But it's not if you remember the 4 steps. It has to be found in the atmosphere. It has to get into the food web. It has to go through the food web. It has to get out. Well, in the carbon cycle, what I want you to realize is the key terms photosynthesis, respiration, and the greenhouse gases. Well, where you find carbon dioxide is really simple. It's in the air as gas, CO2. And plants are going to take it in through photosynthesis, making food, and animals are going to eat the plants. So then we are going to return it by the process of respiration, or breathing it out. Now, this animal here and the plants could also return the carbon to the atmosphere if they died. If they die, this cat dies, or the plants die, and they get buried to make fossil fuels, and you burn it, look what happens. Industry burns the carbon dioxide, the coal or oil, and it burns it, puts it back in the atmosphere as CO2. That means plants can suck it up again. It goes through the cycle again. Great. But what happens if you have too much CO2 produced in the atmosphere because you're burning too much? You get what's called the greenhouse gas effect. And that's one reason why we're having a high rise in cancer cases recently. We're having our atmosphere blanketed with the CO2, so any sun radiation that comes in hits the ground, bounces back up, and can't get back to the atmosphere, can't get back into space, so it just keeps bouncing back and forth, hitting us, causing increase in skin cancer. That's the carbon dioxide cycle. Okay, now carbon dioxide can evolve quickly through the organisms. The long-term cycle, that's where we get peat and coal and gas deposits. It's over long periods of time. Animals are buried and then we take them up and burn them. In the short term, we're putting a lot of carbon dioxide up because of burning the fossil fuels. The nitrogen cycle is a key one. Now I want you to pay very close attention to this nitrogen cycle because it can get very complicated. Watch my pointer. I'm going to start up here in the corner. Nitrogen's found in the atmosphere as gas. And it gets in, follow the blue line, by plants sucking it up. And these things called nitrogen-fixing bacteria are going to switch that gas into a liquid that plants like. So follow my arrow, please. plants will then suck up that liquid. It uses it to grow. Geez, I wonder where that ties into your life. Plants are using something to grow. It's called a fertilizer. Fertilizers help plants grow. So plants are going to suck that up. It's now entering the food web. It gets passed from herbivores to carnivores. This herbivore is going to pee on the ground. This carnivore is going to pee on the ground. This herbivore might be eaten, and this guy will poop its waste on the ground. Well, when you put all that waste back on the ground as liquid or solid, it seeps down to the soil, and then these things called denitrifying bacteria are going to change it back from a solid back to a gas, and it's back in the atmosphere again. So it's a constant cycle. Watch my arrow again. Atmosphere, food web, passing through the food web, out of the food web, recycle back up. Now, how we're messing this up is if farmers put too much nitrogen on the soil, okay, through manure or fertilizer, it can leach into the water, causing too much of a bloom or boom of growth of plants, and that can cause serious consequences later on. It's called eutrophication. The very last one I want to do is called the phosphorus cycle. This is very simple. You can see that phosphates are found inside rocks. We're going to start right here. Okay, it's solid rocks. Well, water is going to break down those rocks, and it's going to be on the soil now. So now the plants can suck up that phosphate because it's now mixed in with water. Plants suck it up. So here's it is in plants. Plants get eaten by the animals. Animals pee, poop, or die onto the ground, and when they do, the phosphate's put back on the soil. And over time, that soil might be compacted again, and we're back to rocks. Now, think of just like a nitrogen cycle. The way we're messing this cycle up is by having too much fertilizer put on the ground, causes runoff into the water, and we have a spike in growth of plants. Well, plants are living things also. So if this plant is out competing or using up, is growing really fast, using up all the resources, well, at some point it's going to hit its carrying capacity and die. And that's going to cause all the plants to die in the water, which means the food for these guys go down. They're going to decrease. Just a big mess up. So we got to be careful about how much fertilizer we're putting on soil. In the short term, don't worry so much about this right now. Phosphorus is cycled from the soil to producers and then from the producers to consumers. In the long term, it's the weathering of rocks. Okay, so that's where the phosphorus comes in. So you should know for phosphorus the concepts of weathering, erosion, and eutrophication. So in conclusion, very quickly here, biochemical cycles include the exchange of important elements from abiotic to biotic. The carbon and oxygen cycles are closely connected. Nitrogen gas is limited in its ability to enter the food web, so it has to be fixed, and phosphorus and carbon both have a short and long-term life cycle. Alright, ladies and gentlemen, if you go back to Moodle and take the Section 2.3 self-check, you should be ready to start the class tomorrow. Thank you for listening, and I appreciate you being here today, and I can't wait to see you guys in class. Have a good day.